everyone, my name is Gabriel. I work at 01. I tell computers what to do for a living, and sometimes they listen to me. I'm here to talk to you today about service objects, but let's get into the agenda. I'm going to talk to you 4 things about me, just so you know who you're dealing with. I'm going to talk to you about what coding was like for me before I embraced service objects and how they made my day better. I'm going to tell you what service objects are and how they can make your life better, and then what's going to be in it for you. After that, I'm going to do some CDD. And live code a service object for you because I'm pushing my luck. And I'm going to walk you through some tips and tricks for service objects and how you can make them even better in your day. Okay, some 4 things about me. That is my wife and son, Anthea and Constantine. In fact, they came to surprise me. Say hello, everyone. I have 2 dogs, Blossom and Buttercup. They're quite rowdy. And I run a software development company called 01. 4th thing is I play way too much Destiny. So that's my PSN account, G4. Let's raid, please. Seriously, let's do it. Okay, I want to talk to you about like what my coding was like before I embraced service objects, before I discovered them. And it really is. It's the bad old days. But there's no shame in how I used to code, because you can really only appreciate where you are today when you look back on how your life used to be and use that as a contrast. So if you guys code like this, there's no judgment, but hopefully I can teach somebody something useful, and you can walk away from this with some new skills that will help you out. Before I get into that, I just want to ask, who has 5 years or less experience? Software development. Okay. All right. Who has like there's like 10 years, but like 1 year times 10? No. Okay. So the people that have 5 years experience or less, this is going to help you the most. I think anyone that's got more experience is still going to be valuable, but for those people, I would ask you to really pay attention and have some good questions queued up, because there's something in it for you at the end of this. Okay, so who puts logic in their views? I used to. Sometimes it's just easier to do that. And, you know, Rails has got convention over configuration, but Ruby is just kind of like, you know, whatever, I'll execute wherever you put your code. If the cursor gets there and there's some code there, I'm going to run it. Doesn't care. So you can really do this if you want to do this, and sometimes you're kind of forced to do it. Don't read too much into the code, guys. It's there's no meaning there. So this code, like it's doing stuff in the view. You don't want to do this. Your logic becomes way too connected to the view layer, and reuse becomes a big problem. So the logical next step, if you are the kind of person like me who used to put logic in their views, is to put your stuff in controllers. And this looks better. I think it's objectively better. You put your stuff in a controller, your logic in a controller, but it's still not super great. The reason that this is not a good way to model your software is because your logic, your business logic, becomes tied to a web request, and it becomes tied to parameter extraction, and this inherently limits you. You cannot use this code outside of the context of a web request. So everyone can agree that, you know, this is probably not the best way to do it. Like, let's find a better way, and everyone's going to go, well, you know, we're in Rails, let's just put our logic in the model. And who does this? Nobody. A little bit. Honesty, I like it. Okay. This is better. This is, again, objectively better. But it's a distant second to what I hope I can show you and teach you today. The reason that I don't like putting my logic in models is because, especially in the Rails world, Rails has kind of butchered the M in MVC. Your model is really meant to represent your entire business domain. But in Rails land, your model is your entity. It's the thing. It's the data. And it's not the domain. It's really just like the account or the user or the product. It's not the actions that happen on those entities to bring out that business logic. That's your domain, and that typically doesn't fit nicely in a model. If you've ever found that you've had models that are like 1,000 lines long, or you've got one model that's like reaching down to 3 other models through chaining and associations, that's a sign that something is usually wrong with your design, and your code's probably not in the right place where it needs to be. So to summarize, there's a downside here. And the downside to doing this, to modeling your code the way I've illustrated there, is that you have a single use context of your code. Wherever you put it, in any of those 3 scenarios, you are typically constrained to using it in one place. With the exception of models, you have a little bit more flexibility, but it's still quite tricky. It makes your code really, really hard to refactor because it's muddled up with active record, or it's muddled up with view logic, or it's muddled up with, controller action dispatches. And as a result of that, it becomes very difficult to extend. It becomes painful to test because you have to exercise your entire stack, and you're mixing your concerns. So, what do you do when you're faced with these problems? If you're like me, you stumble across an article somewhere on the web, and you meet service objects. So, for me, in my career, I never had a level up moment in the way that I did until I met service objects. Let me walk you through what that is. So what is a service object? In short, it's just a plain old Ruby object. But what it does is it decomposes your business logic into classes and methods that you can then implement. It's the domain to active records entities. This is a very, very basic definition, and there's a lot to unpack in what this really small statement is. So I think what we can do is dive into what makes a service object great. So for me, a service object does exactly one thing, and it's preferably by a single public method with a very, very bland name like call or execute or process. For me, service objects are really great when you can chain them together. So you've got discrete business actions, chaining them together into a business process. That makes them great. And they're awesome when they can return complex objects. You don't ever want to use service objects that just return a Boolean true or false. That's not very helpful. You want service objects to return success or failure, some kind of status predicate. You want them to return payloads of data back. That's when they start becoming very, very useful. And also, you want service objects to roll back if possible. So things go wrong, things break, a database is not available, an API has fallen over, someone's credit card got declined. You want to be able to roll those transactions back. So if you can do that, that's a good sign that you're working with good service objects. But let's get meta. All right. So there are 2 kinds of service objects that you typically find in the wild. The first is actions, and the second is organizers. So an action is a discrete piece of business logic. So that could be calculate shipping or allocate stock. And then you have organizers, and an organizer's sole purpose in life is to string together other actions to compose these larger business objects. So if you are calculating shipping and if you are allocating stock, that's part of a larger business object, business process, which is place order or buy product or something like that. So using these 2 together, using organizers to sequence these actions, you can get very, very complex business processes down into very manageable chunks of code. So what changed for me when I started using service objects in my code? Because a lot of stuff actually just as a consequence of coding in service objects, like what changed for me? How did things get better? So, tests became super easy. Tests effectively become like you're testing a function. You give it some input, you're going to expect some output, and as a result of that, they become really stub friendly. So you can send it mock objects, and it's going to work really well with that if you don't want to spin up huge active record objects or big API clients. Changes to requirements become a much less combative argument with your business owners. They go, well, I've decided we don't really, want to do this thing anymore. We don't want to calculate free shipping. We want to, test what day of the month it is. And if it's a day ending in Y, we want to give someone like a 10% discount. So these things, when people say this to you and you're using service objects in this way, things become very, very simple for you. Your architecture becomes change friendly, and you have a limited blast radius for these changes. So the other thing is reuse becomes a reality. There's a lot of times where you might have a piece of business logic that you need to reuse over and over again. Something like test that an account has an active subscription. So wouldn't it be great if you had a discrete action that you could reuse across all of your objects, all of your service object organizers, slot it in as the first action. If this account has an active subscription, continue with the process, otherwise exit early. A lot of times you have to remember, call this model, check this predicate, and then do some special logic if it doesn't work out. You don't have to worry about that kind of stuff anymore. You just slot that action into your list of sequenced actions in an organizer, and you're good to go. And as a result of all of this, you start having far lower overall code complexity. And this is not just me saying, it's simpler. Objectively, it is a lower code complexity. If you take Flog, which is a code complexity static analyzer for your code, and you run it against your models when you're not using service objects, you will find that you have an unbearable amount of Flog pain in your code. The minute you start extracting all of that out, your Flog score actually becomes ON or O1, becomes static, and objectively, your code becomes simpler. If your code becomes simpler, more people can use it, and less complexity equals higher quality, because you don't have to handle all these crazy edge cases. You can hand code off to a junior, and all they need to worry about is that particular action. They can test the hell out of it, and overall, your project becomes far more successful as a result. So what is in it for you if you start using service objects? Okay, so I'm going to ask that question by asking a few more, answer that question by asking a few more questions. Who can tell me what this is? I'll zoom in a bit. What is that? It's a Rails app. Kenneth is right. But what does it do? I don't know, right? Okay, I'll expand the model folder for you and zoom in on that. Can you tell me what it does now? I see things like event, quote, stock, venue, voucher. So, it's great if you DHH, not so great for the rest of us. Everyone can recognize a Rails app, but that's where the value ends when you're trying to grok a code base. Everyone goes, oh, well, it's Rails, like I'll just slot right in and, But for me, I need more than that in order to get up to speed. What I'm going to do now is expand an organizers and services folder in the same project. And I'd like you to tell me if you can tell me what this application does now. There's a bunch of services. We'll come back to them. Here's some organizers. Can you tell me what the application does now? Well, it accepts quotes, claims vouchers. You can create events. You can reject quotes, send vouchers to clients. It looks like some kind of event thing where vouchers are involved and there's maybe a bit of quoting interaction going on, right? Pay attention to that claim voucher organizer. We'll dive into that in a minute. And here's the services again. Okay? All of these services do one very, very simple and targeted thing. They create a quote, or they find a voucher line item, you know? Okay. So, I think it's a bit clearer now, right? Let's dive into that claim voucher organizer. So, claiming a voucher is a multi-step process. It's a business process. And in order to claim a voucher, you need to find the voucher for the event. You need to reserve that voucher. And then you need to claim that reserved voucher. And what we do is we have a .call on the class. The class is the thing that tells you what it does, not the method in the class. Take some params, we extract those params out. It's really just a hash of key value. And then we reduce that business process down via its actions. At the end of this process, we get a context object out, which has some stuff in it for us. Maybe it's a status of the voucher, maybe it's the voucher name or who used the voucher, I don't know. It's been a while since I wrote this code. And we also get a success predicate out of it. So you'll see over here I'm using a thing called light service. Light service is really just, it's a framework that I use for managing my service objects. We can write our own, in fact I will in a minute, because I'm crazy. But yeah, so what's in it for you? Well, you're going to get some clear architecture on your code. It's going to be exceedingly clear what your application does. And you're going to get simpler feature refactoring. So here's the process for logging a user in from OpenID Connect. Okay, so today we get fetch existing user for OpenID payload. We then create the user from the OpenID payload, and then we issue a cookie. That's cool, right? Okay. But now we don't want to issue cookies anymore. We want JWTs. So what do? Well, you just throw that one away and put the JWTs in, and you're done. Simple feature refactoring by slotting in actions in and out. You also have very modular logic at your process layer. So what does that mean? Well, here's the login user, but maybe you want to extend this logic. And why do you want to extend it? It's just a login, right? Like you're just logging in a user. Why am I over-engineering this? I'll tell you why. Because, spoiler alert, the future happens and things change. And today, this is all that's required. And in the future, we're going to need to do some more things. We're going to want to do a send welcome back email. And we're going to do an update while you were gone notification. And not being able to architect these things within the context of this framework makes things very, very, very difficult. Okay. So testing becomes great. Actions, they're easily stubbable and mockable. They have inputs and easily testable outputs. You should treat your actions like unit tests. And organizers, they take code on this whole journey. They effectively test the stack of your business process. You should treat these organizers as integration tests. And why do you want to do this? Why do you want to treat these things like that? And the main reason is because you get use out of outside of your web requests. Your application is more than just a series of HTTP transactions. So you can use them in web controllers, but you can also use them in async jobs. And now you can use them in rake tasks. You can't do this kind of thing if all your code is embedded inside your controller. And transactional mailers are coming out in Rails 6, so there's another place that you can use your objects without having to lean on a controller. Another thing about controllers is they become super, super boring. This is a typical controller for me. This is it. I execute an organizer, I test its success value, and then I set some IVARs for a template, or I render an error. That is it. If your controller action is more complex than this, there's probably room for optimization. And you want to resist the urge to just like take your params and send them in, because then you're coupling your organizers and your actions to a web request once again. So should we build one, guys? We roll the dice. Oh, wait. Okay. Let's, yeah. There we go. Okay. I'm going to have to escape. VS Code. All right, so over here. All right, so I'm going to build a very, very simple object, service object. Isn't this amazing? Look at that. Ta-da, check on. Okay, but seriously, so we can do that and call it a day, and that's your service object framework. But what we're going to do is we're going to just expand on that a little bit more, and we're going to build we're going to put that into the base method. Okay, so we do a .call. Okay, so we say it was called. We set a flag to say that this thing was called. The result is the super object that inherits from it, and then we return itself. Okay, let's see. We need the result reader. There we go. Years of practice, people. Okay, so we need to test if it was successful. So we check, was it called, and is it not a failure? And then we put a private method in, called, and called will just, check the IVAR, and we'll give it a default of false. And we need to do failure, okay, called, and are there any errors? Errors any? Okay, great. So we build the errors in. Errors, we'll give it a default of error new. Errors new. Let's build the error class. Okay. So we're going to first put in a not implemented error. And we'll put that as a guard clause back in call to make sure that someone actually does implement the .call method in their service object. Okay, go back up. Okay, let's build error class. It's really just going to be a hash, but we'll have a thing for adding error keys. Error key, we'll default it to an empty array, put the key value in, error value, and we are done. Good, okay. Okay, let's, okay, so we are going to call this service obj. Wait. Yeah. Okay. Let's build the actual service object. We're going to require service object that I just created over there. Don't forget the shebang. Awesome print, bring it in. It's a bit of a difficult angle for me. We're going to make a thing called make millions. Okay, we're going to bring in our service object framework that we've just built and initialize it. Okay, cool. Let's build a call object. Step 1. This is the thing. We are going to beguile your audience with a contrived example. Outcome is, we're going to call it make millions.call with step 1 is the argument. So if outcome success, AP outcome result, and if it's a failure, we'll print out the failure. And now let's implement the actual service object. Go back up. Step 1, put it in an IVAR. And then we're going to implement call. So if step 1 is null, plop an error in and exit out early. Got to start somewhere, man. Okay, and we'll return early. Okay. And then we will return something over here called step 1. Step 1. Step 2. Step 3. Profit. Okay. That's cool. Make millions RB. All right. Cool. And now we can run it. Okay, don't worry. I've got it in a backup directory. Okay. I'm not that crazy, guys. Jeepers. Okay. So we can run make millions RB, and there we go. Beguile your audience with a contrived example. Step 2, something, profit. Okay. All right. We're on the home stretch now. How much time, Kenny? Cool. All right. So let's talk about some tips and tricks. So the first thing that you want to do once you start getting comfortable with service objects is you want to start thinking a little bit more about how you name them. And you want to make sure that you name your organizers after business processes. And you want to make sure that you name your actions after the steps in that process, like I highlighted earlier. The one thing that you don't want to do is you don't want to name your actions after some kind of implementation detail. So invite friend is a better example than create linked user or associate one user to another user or something like that, because that's not what it's about. It's about inviting a friend. Namespacing is also encouraged. One thing I would also recommend is don't be like me and build your own in front of 200 people. Rather just pick a framework and start using it. You stand on the shoulders of giants, and they're pretty cool. They offer a lot more features than you can get from just doing your own thing. So the first one is a thing called Interactor. It's built by the guys at Intridia or Collective Idea, I'm not sure. It's battle tested, it's very simple. Its core features have all the cool things like organizers and rollbacks. It's got some cool plugins. One of them is Interactor Contracts, which uses dry validations. I think I know the guy that wrote that. And yeah, and you can use it to like test that your inputs and your outputs are matched. I use it quite a lot. The other one is Light Service. It has exactly the same features as Interactor. It's got a very cool developer, very responsive guy. And yeah, again, recommended. You can't go wrong with that one. There's another one called Whisper, which is a little bit out there. It has a more of like a non-traditional publish subscription model. So you have these actions, but they're executed by publishing them onto like the Whisper queue. Or you can use DryRB. I think I've seen this guy somewhere before. Anyway, it's very, very powerful, but you got to do a lot of plumbing yourself. Okay. One thing which is quite weird is Hanami and Trailblazer have got these built in as first-class features in the frameworks. It's kind of weird that Rails doesn't have this, especially now. Like we're at version 6 in a few months. It's quite strange. Anyway, one of the cool other things you can do is you can programmatically generate your action sequences. So this is a thing called process order. What it does is it takes a whole bunch of actions. It takes params and it compiles the actions for the parameters. Sorry, someone's calling me. And it compiles the actions for the parameters and programmatically generates a custom sequence of actions for you depending on what your initial parameters are. We actually use this for a customer where we're generating some docx stuff for them. We're generating a docx report, and one client has a very, very particular set of requirements for this feature, so we take them down a completely different set of action paths, and then for all the other users, they go down the standard action path. Yeah. And I mean, it's really just like a bunch of parameters that you're sending to call or reduce. So why not take advantage of being able to programmatically generate them at that point in time? Okay. And then my favorite one is hybrid service objects and async workers. So service objects love Sidekick. You don't need a separate worker class. That's actually just like class bloat, in my opinion. What you can do is you can take your service object organizer and implement the .call, which does the stuff, but then you can have a .perform in there, which is your Sidekick entry point. And then you can have a hydrate function, which takes the primitives that Sidekick gets, hydrates them into rich objects, and then calls itself using .call. And then if the outcome is a failure, as you can see sort of toward the middle of that picture, just raise some kind of exception so that the Sidekick job retries. And that's it. Thank you very, very much. My name's Gabriel, work for 01. We're hiring. And seriously, I was not joking about the Destiny. Let's play. So, sorry, Rory. I do want to take questions. And the reason I want to take questions is because I'm giving away some stuff. There are prog books that I am giving to anyone that asks really good questions. and then there's a super secret awesome prize right at the end for the people that put their hand up in the beginning. Okay, so the question was like, what do you do when you're stuck with a monolith? How do you, get onto the road of service objects? Well, you start. Any new features come in. You can maybe negotiate with your line managers to work on refactoring features that need you to work on them now. If you need to build in something new, well, hey, can we move this into a service object framework as part of the project process? You get a book. Docker for Rails developers. Yeah, this guy over there. So the guy's question is, I use transactions for catching bad scenarios. Like, how does this work in the context of service objects? So what we do, I don't know how it's going to work for you, but this is how I've done this in the past. If I create something, I just create it, I store it in the context object that gets passed around through the different actions, and you must implement a rollback. The frameworks that I showed have rollback functionality. So when something breaks, if that thing is rolled back, you check if it's in the context, and if it's in the context, like either delete it or change it or handle it there. You don't have. I wouldn't rely on transactions. Transactions, especially for like long-running tasks, are going to lock your database. They're going to cause like a lot of really sort of hard to debug problems. But as long as you've got that rollback functionality to lean on, it doesn't really become a problem anymore. You get a book, Agile Web Development with Rails. Ben. Magic fingers. Shit, man. That's not technically a question, but you get a book. Programming Elixir 1.4, or was it Phoenix? Whatever. I don't know. Yeah, so that was a very contrived and localized example. I have been very guilty of putting some like serious business logic into my views. That was probably quite a tame example. So decorators are still a good thing to use for views. Things like Draper, still continue to use them, but avoid putting like if you've got an if statement in your views, you're probably doing it wrong. I need someone with that put their hand up at the beginning to ask a question. Did you put your hand up in the beginning? Okay, cool. Sure. So his question was, if you're building so many if you're building all these service objects, when you've already got things like concerns in your code, how's it going to? Is it not really going against Rails convention? Absolutely, it's going against Rails convention, and I think this is one of those times where it's totally fine to do it. It seems like the general mind share is moving in that direction anyway. The other thing is that you need to ask yourself, in what context are you using the code? Are you going to be using it outside of a web request? It's a very good idea then to move it out into service objects. And you don't have to be dogmatic about it. Like if it makes sense to keep it nice and simple and put it in the controller or the model, whatever, just do it. But like the minute your code starts becoming bloated, you need to then refactor. So it doesn't have to be from day one, but you should keep an eye out on if your code is getting complex. And that was a really cool question. And because you put your hand up in the beginning, you, sir, get a 1-year subscription to Rubyfuza. Cool. If you guys have any more questions, talk to me outside. Thank you very much.